As data volumes and velocities rise, many data engineers are scrambling to stay ahead. Modern data pipelines are the answer as we explore on this episode of Future Proof, which was a preview of the Zero Gravity online event.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly, Eric Cavanaugh here on the road today, doing it from a different location than I normally do. So that's kind of fun. But nonetheless, we're going to have a good time talking to two experts today in the field of big data, in the field of data pipelines, modern data pipelines. And this whole event really is a teaser for the upcoming Zero Gravity event that's not too far away. If you want to find out more about that, just Google Zero Gravity Summit and add Incorta in there if you want to get the most accurate results. That's Matthew Halliday's company. He's on the call today, Incorta. Just Google that. We'll also hear from Jacques Nadeau, who has started a new company, but he is the co-creator of Apache Arrow, which of course is a very interesting technology that's enabling rapid queries on data lakes, on massive amounts of data. So the Zero Gravity event has a bunch of great speakers, including Thomas Kurian, who is head of Google Cloud these days, as I recall. He's been a real luminary in the field for, 20 plus years or so. And obviously that was a sign that Google is getting very serious about their cloud offerings. And let's face it, multi-cloud is a reality. And cloud is the new center of gravity, if you will. Granted, it's up in the cloud, so that's kind of an inverse situation of what we're normally talking about. But the bottom line is there's a lot of data on-prem. It's going to stay on-prem, most of it. There's a lot of data that's being created in the cloud. But how can we build modern data pipelines to be able to leverage and access this data to do our analysis, to figure out what to do next in our business? And so with that, let me bring in our first guest, Matthew Halliday of Incorta. They, of course, are putting on the Zero Gravity event. Matthew, welcome to the show. Tell us a bit about your thoughts on why zero gravity and what's up with modern data pipelines.
Yeah, great to be here. Thanks, Eric. So this event, I think, is really timely. It's actually the first industry event around a modern cloud data pipeline. And it's really designed to bring data engineers, architects, analysts, data scientists together to explore really how to build in this modern world and manage data pipelines on cloud infrastructure. So one of the things that I think is really fascinating, right, that's going on in the industry right now is that really the sense of urgency in being able to deliver data is now more than ever before. It's also takes a long time to actually get that data into the hands of people who make those business decisions. And so understanding all of those components and like how can we bring analytics to the people who need to make those decisions in that moment is becoming more and more pressing. It's becoming more need for real time, and the nature of being able to understand your data and to make intelligent decisions with it is now more important than ever before. As a company at Incorta, we've seen the entire end-to-end flow. We've seen people coming from connecting source applications, starting with the business applications, all the way through to making the decisions. And that really helps us have a unique perspective in terms of where we see this going. And so with that, well, we're able to bring in a whole bunch of industry experts to help speak to these different areas to really talk about what are some of the challenges that are uniquely facing certain companies. So you can take like Meta, for example, who's going to be presenting on when one size does not fit all, general purpose versus purpose-built data pipelines. So obviously Meta or Facebook, as they're previously known, has dealt with huge volumes of data and have been very instrumental in building some of the largest data platforms out there that are crunching huge volumes of data. And yet, when it comes to how you might handle your business application data, you might actually find it's interesting that they use different solutions that they don't use for things like clickstream, advertising data, et cetera, and things like that. So this is, I think, a really exciting event that's going to bring together people understanding visionaries, thought leadership from a variety of different companies, not just hearing from one, right? We want this to be different perspectives, different views, and just share some of the great wins that we're seeing in the industry, because I think there's some things to celebrate. We still have a lot of work to do, right? The success rates in these projects are not as high as they should be. But we think there's some exciting things that if people came to this conference, they would get and learn from some people who've done some really great things, and share between different organizations, different people, so that we can move the needle forward. Because I think everybody who's coming to this conference, who is going to be interested in this conference, really is going to care about one thing. It's they believe in the value and the importance of data, and they believe in the value and the importance of making sure it's actionable, and it's actually can be tangible in terms of what it accomplishes and does for business and for people in general.
Yeah, that's a great summation. And like I say, folks, hop online to Incorta.com/zero-gravity. That's Incorta.com/zero-gravity. Netflix will be presenting, Meta will be presenting. And, you know, Matthew, I look at the world of data these days, and what's really exciting is that you have these tremendous innovations happening at cloud scale, but that doesn't mean only big companies can take advantage of all of that. The new dynamics, and open source as part of this, are such that small and mid-sized companies can do tremendous things with large amounts of data, assuming they set up the pipelines, they do the analysis, they kind of close the loop. But the point being, it's not just for Fortune 2000 companies, right?
No, I think really what we've seen is data's become a product, right? Where we've heard that kind of phrase before. And what that means is innovation starting with product. And I think actually gives the leg up to these companies that maybe have been built from the ground up with data being viewed as a product from the get-go, right? It's not an afterthought or something where they say, if you're a Fortune 1000 company, you've probably been around for a while, right? You have very established business practices and procedures. If you're a smaller company, a startup, mid-market company, you have that luxury, maybe being a little more agile, being able to take data and say, and bake that into your strategy. And maybe data is actually a part of your strategy. The way you think about data is certainly different, right? The way we've been thinking about data over the last decade is different than it was 20, 30 years ago. So you're in that unique opportunity really to leverage some of these great technologies. The cloud makes them accessible. The cloud makes it really a low barrier of entry, right? Prove out something in a way that you don't have to make huge investments. You don't have to go and get a 400 node Hadoop cluster and go through all of that expense to kind of just try something out. In the cloud, you can go spin it up, see what happens. If it works, great. Build your business value from that, then it'll make the solution worth the money you pay for it. Whereas before, just the cost of entry to these analytical and data solutions was just so high. It wasn't just the expertise, it's obviously the cost, the software cost, the hardware costs, everything, the administration, and you wouldn't even know if it'd be successful, right? So I think that's where it's really exciting for those companies to leverage the cloud and to see exactly what could they do with data. So really, it becomes down to like your imagination is your limit in some respects in this new kind of world that we're in.
Yeah, that's very exciting stuff. And it's all sorts of different data types now, right? Depending upon your business model, you can get signal from any number of data sources, whether it's clickstream analysis, production systems, whether it's if you're in the business of building software, your engineering teams having data from all sorts like Splunk and things of this nature. There are so many sources that you can cobble together fairly quickly to build these pipelines and to get yourself very acute views of your business, which metrics you need to follow. And that's what helps keep everything kind of humming and the trains running on time, right, Matthew?
Absolutely. I mean, just a personal story that I had, right? So you talked about product analytics. So we have an Incorta product, and I wanted to analyze how is our product being used. So we used a product called Heap and another one called Full Story. But when we pulled that data in, it was amazing. The very first time I had access to that data in the cloud is very easy. We set it up, we started collecting data. And then it was like a Thursday evening at like 9 o'clock, I got my hands on that data and I started looking into it. And it was fascinating because I was looking at my data, the data that was relevant to my business. How are users using our software? Next thing I know, it's 2 o'clock in the morning and like 5 hours had disappeared. But that's the difference, right? It's like that time to value and being able to explore your data or have visibility into your data that you've not seen before. That's exactly what this whole conference is about. How to enable those kind of experiences, but every different different data type or different data source is different. Mine was an application data, so it was largely around click information, what people were clicking on, when were they getting rage clicks. Well, if you're a financial controller, you're going to be looking at something different. You want to understand exactly the accounting and drilling down into subledgers and accounting journal entries and batches and journals. And so having that visibility will get you excited when you can do that, which is a different data pipeline than if you're looking at sensor data coming off of a solar panel and you're trying to understand exactly what's going on, longevity of the panels, predicting if there's maintenance going to be needed. Like all of these things are really interesting, that the data is the lifeblood, but in reality, it looks and takes on very different characteristics and has, in its essence, I would claim, very different DNA that requires you not just have this kind of one size fits all, right? I just build for scale and then that solves every problem. I think that's a bit of a mistake that kind of people think about data. It's just like, how large is it? You know, how much data? And the metric they're looking for is, you know, how many petabytes or how many terabytes or zettabytes or whatever it could be, right? And that's kind of the piece. But it's interesting when you look at data sets that maybe are much smaller, but you put them across like thousands of tables. And the next thing you know, like you could have a system that could run, you know, hundreds of petabytes of data and crunch and process that data very efficiently. But you put, let's say, a 50 gigabyte financial data set on it, and that data pipeline will not work, and it doesn't perform in the way that you need it to. So it's going to be really interesting to hear about all these different use cases from media companies like Comcast, Netflix, talking about the use cases they have, all the way down to other companies as well, and what their approach has been.
Yeah, that's a great point too. And, you know, just for the benefit of our audience out there, some folks might be thinking, well, wait a minute, don't my applications that I use, don't they have reporting features? And can't I just use the reporting features in my application? And the short answer is you can, but the real magic comes from being able to correlate that with lots of other data sets. And it's not as simple as it was 20 years ago, where it's mostly ERP data, for example. There are different data models and different data structures that you have to kind of align to be able to get these views. So the answer is not really. You can't really rely. I mean, you can get some value from that, but it's much more valuable to see all the data within a very particular context, which is the workflow of your business, right?
Yeah, absolutely. I mean, even that ERP example, right? Today, I don't think I speak to customers who only have one ERP system. It's very rare, quite honestly. There's multiple ERP systems. And even if you go with those vendors and say, hey, we've got reporting solutions for you, even with their own solutions. So it might be a company that has a cloud solution like Oracle Cloud ERP, which is, you know, a product I actually helped build back in my day. But if you want to look at Oracle EBS data, because you got an on-prem solution, you got a cloud solution, you're trying to stitch the things together, and then you throw in the mix some other applications like Salesforce and ServiceNow, and then all of a sudden you're like, I've got this data all over the place. How do I get a consolidated view? Because at the end of the day, we know that these are all interactions that you're having with your customer, and you need to understand how they tell the full story. The full story is never caught or captured just in one place. It's not in your general ledger. It's going to be a combination of general ledger with support tickets, with all the other pieces that go around it, sales opportunities, marketing information. And so being able to bring that together and be able to bring that to the surface, yeah, it's absolutely goes beyond those bounds and those kind of those individual solution reporting things that you can get, because the narrative is very much kind of told at an aggregate level in each of those siloed applications. But really, you want to go down and understand the nuance between how the things are connected, how those events impact each other, how does number of tickets potentially impact revenue, pipeline opportunities, risk of churn, all those kind of things, bringing them together and being able to look at that, look at a budget, a forecast, and a plan, and be able to tie all of these pieces together in one way that you kind of actually feel like you're making informed decisions versus just kind of getting knowledgeable in a certain silo.
We're talking all things data, and we're talking in particular about the Zero Gravity conference that's coming up soon. Hop online to register for it. It's a free conference online, Incorta.com/zero gravity. Incorta is like it sounds, Incorta. We just heard from Matthew Halliday, co-founder of Incorta. And next up, we have Jacques Nadeau, who is a co-creator of Apache Arrow, a very, very cool open source project that is revolutionizing querying on data lakes. So Jacques, let me bring you back into the show, or bring you into the show for the first time. Tell us a bit about your background and how you are trying to democratize analytics.
Yeah, no, absolutely. Thanks for having me, Eric. It's really interesting. I've been involved with open source for close to the last 10 years now. And what we've been able to see open source do is drastically change the availability of technology. What used to be something that you would have to buy a commercial product to solve for, you would potentially have to talk to a bunch of consultants to sort of build something custom out for yourself. This sort of over the last 10 years, especially, we've seen a huge increase in the set of technologies and tools that people get to solve their different data problems. And so when you look at some of the speakers at actually Zero Gravity, you can see that a lot of those speakers come out of open source communities, open source technologies. For example, I think that we've got Maxime there, who was a co-creator of the Superset project, the Apache Superset project. We also have some members of the DBT team, another really interesting open source project that sort of changed things. I've worked on a number of open source projects, as you mentioned, was co-creator of the Apache Arrow project. We started that 6 years ago. I'm really trying to sort of redefine how many tools could be available to different people. And so open source has this unique capability, and it has this ability to say, hey, if there's a lot of different people who are struggling with the same kind of problem, there's an opportunity for those people to come together and collaborate to solve that problem, rather than trying to rely on some kind of commercial entity to do so. And that's really what happened with Arrow. And so Arrow's done amazingly well. You can go back and look at the discussions that we had 6 years ago when we first launched the project. I think that I made a prediction at the time that half of the world's data would be moving through Arrow within the next 5 years. I'm not sure that we hit 50%. But we've done very, very well. And so, for example, Arrow, I think, had more than 46 million downloads in January alone this year. Nearly 1,000 different contributors have contributed to the project. And what it's really doing is it's democratizing people's access to sort of modern tooling for data in sort of very advanced ways, right? So there's always been tools around. I mean, hey, man, Excel, the best sort of data tool that we've had in our sort of, tool belt for the last, 30 years. Is a very, very powerful tool. But as you get to sort of more advanced kinds of approaches to data, working with larger and larger scale data and trying to do more kinds of advanced analysis, you need more powerful tools. And Arrow was and has been sort of a very successful way to sort of build up a set of technologies that allow people to work in whatever language is comfortable for them. So one of the sort of big shifts in the market has been the rise of the data engineer. And data engineering, we didn't talk about data engineers as a profile 20 years ago. We talked about things like DBAs and software engineers. Those were the two main things we talked about. Maybe you talk about an enterprise data warehouse architect or something like that. Data engineers is this new profile, and it's the sort of what's happened is we've seen sort of this merger of people who have some set of software engineering skills along with a bunch of interest and sort of focus on data. And they've really changed what's happened in the world, because it used to be that only a small group of people in the world would build tools for data infrastructure problems and data engineering problems. But all of a sudden, when you take what were DBAs and say, hey, let's give them a substantial amount of sort of programming capabilities, then they're working day in and day out on these different data problems. And as they do that, they start to realize that there are tools that they don't have that would really help them to solve new problems. And so we see them create all of these new interesting open source technologies because they're close to the problems. And they are, there's this comment that, engineers are lazy. And the reason is they don't want to have to do something manual over and over again. So they're not actually lazy. They just don't want to do something manually.
Right.
And we definitely see that with data engineers, always building new tools to make things easier and faster to do, to focus on sort of the higher value work. And so open source, I think, has been sort of this really interesting multiplier for so many people in doing that. And I think that a lot of that now is driven by these data engineers and their experience sort of working with specific challenges, specific problems, and being able to resolve those things. Arrow is a great example of that. I think one of the really exciting things that's happened over the last couple of years is the rise of a technology called DBT. So DBT, was consultants working on data engineering problems So they built up some tools for themselves to solve those problems, really looking at sort of how do you simplify and create the right set of base primitives for working on data pipelines. And really came out with a very elegant and useful metaphor for working with data. So that community basically said, hey, let's create a pattern where people do data transformation primarily in SQL, but we combine that with the capabilities of Git to model things and version things and sort of have something sort of fairly self-documenting that's very powerful. And so I think it's a really interesting example of sort of this rise of open source and sort of these data engineering tools that are built in open source, because not only does it give people the ability to work with these data pipelines very effectively, but it also, the community has done a great job of allowing people to extend those capabilities to specific needs. And so, Matthew was talking before about sort of the sort of rise of more and more adapter and connector communities. And a lot of that comes from, hey, I've got a new data source that I need to work with. Sure, people could historically maybe build that technology to solve for themselves only inside their organization. But now when they engage with these larger open source communities, they start to recognize that, hey, if I build this out in the community, then not only do I give value to others, which makes me feel great because it's more than just my own company that's benefiting from this, but it also means I get to share the load. And so, today I build the first version of this connector, and then tomorrow there's some new features in the underlying technology that I'm working with. Someone else maybe picks up and tries to solve for those new needs. And so you basically get this sort of crowdsourced effort against solving these problems. So I think there's really some exciting things that open source in general and Arrow specifically have been able to do to sort of enable these modern pipelines that we have today.
Yeah, that's great stuff. And I'll point out to our audience that open source, it really started with Linux, the operating system, about 25 years ago, I guess. But now it's really been climbing up the stack. And of course, we went through this whole Hadoop era, in which I think we learned a whole heck of a lot about federated systems and distributed programming, which, as you know from experience, carries a whole new set of challenges. And even though Hadoop is sort of getting folded under the foundation now of data stacks, nonetheless, it's still out there. It's a file system. There are going to be a lot of instantiations that aren't going away anytime soon. But the cloud is a big part of what's changing things, and that's kind of pulling data up into the cloud. And I think what you want in your data world is for your data to kind of stay where it is. You don't want to have to be moving data around en masse. And that's one of the main drivers for this whole concept of modern data pipelines, right? What do you think, Jacques?
Yeah, no, absolutely. I mean, I think that, I think there's two different trends that I think are really important here. The first is this sort of continuous sort of replatforming of sort of modern enterprise sort of infrastructure, right? And so like the rise of cloud storage and sort of its importance to analytics has drastically changed how we think about analytics, right? And, Snowflake was great coming into the market early and saying, hey, let's really think about data as sort of as storage as detached from processing. And let's think about how you replatform the world for that. And then we've seen sort of basically additional patterns that are similar to that continue to occur. And so, for example, the rise of the data lake concept or the lake house concept, basically saying, hey, let's treat S3 or Google storage or Azure storage as basically the place where we hold our gold copy of our data or our system of record. And let's build some layers on top of that, but hold that sort of storage there rather than, starting to be required to move stuff from one system to another. I think it's been a really interesting sort of shift moving towards this sort of like, hey, let's replatform this stuff. I think the second really interesting sort of pattern is this sort of, I would say, oscillation between, consolidation of things into small number of tools, and then sort of the disaggregation into more tools. And I think we go back and forth along that spectrum many times over the last 20 plus years in analytics. And so, if you think back to like the early days of big data and Hadoop and those kinds of things, there was this sort of drive to have like 20 or 30 different technologies in the sort of suite of Hadoop technologies that were solving problems. And then more recently, and there were some strengths to that. You could have some really interesting things that were happening, but it was also fairly painful and challenging to work with in a lot of organizations. And you actually had to pay a lot of people for services to help you work with those systems. And so we've seen kind of a movement the other direction, over the last 10 years, where we moved much more to sort of consolidated data warehousing that looked a lot more like how we worked with Teradata back in the day, with the rise of things like Snowflake as a sort of a cloud data warehouse. Well, what's interesting about that is that, the strength of sort of simplicity, right, of a single solution is great. But then, what continues to happen is that after people get to that place where, the base level sort of foundational primitives are all solved, then there's this need to have continued flexibility. And so you start to see decomposition again, right? And so the decomposition looks different each time you go through this process. And this time, the decomposition, some examples of that are like the fact that, hey, DBT is a new pattern for how you manage these things, whereas maybe 20 years ago you do something like stored procedures inside of your data warehouse to solve these problems, right? So it's a shift of where that functionality is existing. Another example of that is that we've started to see a separation of different kinds of storage, right? And so there's a couple of talks at Zero Gravity around I think both Pinot and Rockset, two sort of modern technologies that are focused on what I would describe as sort of real-time user analytics, which is a subset of all kinds of analytical problems. So they have specialization against those particular types of challenges. And so, maybe 5 years ago, it was like, okay, we're going to use one data warehouse for everything. But then you start to realize, well, hey, for certain kinds of situations, there's actually some real benefit to using something that's much more specialized. And so I think that we'll continue to see that sort of cycle back and forth. But the really exciting part about all of this is that every time we see a replatforming, like we have seen with cloud and with sort of cloud data warehouses more recently, what we see is that a whole new set of innovations that occur on top of these new platforms. I think that's what we're starting to see now. Is just the specialization and the really interesting new innovations that are happening on top of these things.
Yeah, those are all really good points. And I wanted to mention too, there's one significant transformation, and you talked about DBT, right, as the sort of transformation engine, right? Because for years it was all ETL. You extract it from a source system, you transform the data, then you would load it into your target system, like a data warehouse, for example. And now, especially with cloud computing environments, it makes more sense to extract the data, then load it into the cloud environment, and then do your transform, where you have all this computational power. Because at the end of the day, it's always about performance, right? It's always about how quickly can I get this processed and delivered and ready for analysis. And if it's not delivered at the optimal speed, then you've kind of wasted your time a bit, right? So tell us a bit about ETL versus ELT real quick.
Yeah, no, I think it's a really interesting sort of dynamic that's changed is the rise of like, hey, like maybe I just land all of my data in the same system. So, and it really is about I think a huge amount of this is driven by the elasticity of compute. So if we, in the olden days, we thought about sort of infrastructure as fixed infrastructure. And so one system was going to solve a problem, my ETL, another system was going to solve my analytical workloads. There are probably different technologies with different infrastructures underneath them. These days, because everything is typically purchased in a SaaS environment as a pay-as-you-go model, then you have a lot more flexibility about what you're going to use to solve each problem. And so one of the really big shifts, as you noted, is that more and more people are saying, hey, rather than have 6 different systems combined to solve my ETL problems, maybe I can actually just drop my data in one of these sort of modern data stores, the data lakes or the data warehouses, and then just iterate with the same tool several times to move from sort of a bronze to a silver to a gold representation of the data. But that those are actually happening all within the same system, as opposed to connecting the transformation to that movement of data. And I think that really one of the really powerful things about this is that part of the reason that ETL historically has been challenging is that you are coupling two things. One of those things is sort of like a physical requirement, which is moving data from one system to another, and another one's a business logic requirement. Transformation is about what particular business logic is going on. And so what happens is that those two different needs have different cycles of change. And so physical requirements don't change that frequently, but business requirements change quite frequently. And by coupling those two things, you basically have sort of a impedance mismatch in sort of the development process of changing these things. And so one of the big strengths that we see to ELT is that you've separated away the physical changes, the physical requirements from the business logic requirements. And so it allows you to be much more agile in the business requirements. And it also allows you to sort of deal with what we used to have as pain 20 years ago, where you'd say, oh, we got one business logic change, or we want to make a change for the last 2 weeks. Okay, we need to rerun all of those physical movement operations as well. So I think it's a really interesting sort of shift, but I think a lot of it is driven by the fact that you have this sort of pay-as-you-go model, you have elasticity of compute, and so people have a lot more opportunity to pick a set of tools that are simpler and not worry so much about like, okay, well, what did I choose yesterday versus today?